Welcome to Phizzy. I am Aditya Mandal and today we shall be learning about vectors. It's a new topic, vectors. Many of you may have heard about it before, maybe in a physics textbook, or you may have watched Despicable Me where Gru's arch nemesis is named Vector. You just got vectored, yeah? And we may not be stealing the moon today, but we'll surely be learning something new, and we'll be learning about the actual meaning of the term vectors. So let's get started, okay? With the definitions, as I told you in the last class, definitions are the most important foundation on which everything in physics rests. So let's begin with the definitions. Okay, so the first quantity I wish to define is scalar. We're not starting with the definition of vectors. You'll learn why. Scalar. A scalar quantity is a quantity which has only magnitude. You know what magnitude means, right? Magnitude means how large or how small the quantity is. Let's say I have a stick and it's 5 meters long, right? So 5 is the magnitude of the term meters, of the length of the stick, all right? Or we say the magnitude of an earthquake on the Richter scale is 7. So that just tells you how bad the earthquake is, right? So a quantity which has only magnitude is known as a scalar, okay? And now we are going to be defining a vector. And there's quite a standard definition to a vector, which is a quantity that has both magnitude and direction. Okay, both magnitude and direction. Pretty simple. Okay, no, it's not that simple. What do we mean by direction? Where does this direction term come from? Right, what do we mean by direction? Let's go back to the analogy we used in the last class. Let's say you are a pirate. Once again, you are a pirate. And this is your ship, your trusty brig, as I told you about in the last class, with a unicorn on the stern. It's got a nice unicorn on the stern. Here's its eye, here's its horn, and this is the bow of your ship, and the ship is called, what was it called? SS Pirate, right? SS Pirate with a main mast. It's only got one mast, that's a bit sad. And this is the sail. This is the sail with both ends connected, and this is you on the deck, and this is the wheel of your ship, which you're not holding right now because you're not steering it. Okay, you're not steering it, I'm sorry, you're not steering it. And you want to navigate the rough seas, the rough oceans, okay? You need to get to a deposit of silver, maybe in the Silver Islands, about 15 knots away, 15 nautical miles away. And so what do? How do you get your bearings right in the ocean? You have something that looks like this, right? Looks like this. It's a circle. That's the body of the machine. And here there's a marking, N S E W. What does that stand for? What does N stand for? It stands for north, right? North direction, south direction, east direction, and west direction. We know, we learned about these, right? These are the 4 cardinal directions, and there's a line joining west and east, and a line joining north and south, and the north and south line has an arrow pointing towards the north, right? And then there is one more. There is a needle, and the needle tells you which direction you are, what your bearings are. Is that right? Is that right? Okay, this is the needle, and this is pointing somewhere between north and east, so maybe to the northeast, not exactly to the northeast, but somewhere between north and northeast. Okay, so what do you call this? This is called a compass, right? A compass. And what does compass tell us? It tells us the direction. It tells us the direction, right? North, south, east, and west. These are the four directions that we conventionally consider while navigating to some point. While we navigate to some point, right? In a similar fashion, in physics, we have something known as the Cartesian coordinate system. Cartesian coordinate system, right? And basically what that entails is you get a graph such as this. It's a set of axes, right? Similar to what you have done in Math 101 maybe. And we call this axis as the x-axis, x dash. This is the origin, y, and y dash. Okay, so this tells us about the direction in with reference to physics, and x is graduated in length units, let's say meters, and y is also graduated in length units, let's say meters. So if we say that we are moving maybe 5 meters east, we move in this direction. 1 meter south, we move in this direction. 2 meters northeast, we move in this direction. So we kind of intuitively get that, right? What direction to move by considering the directions, by considering the cardinal directions, right? So in a similar fashion, the Cartesian coordinate system helps us to glean at the directions in terms of physics, in terms of vectors, right? Now let me ask you a question. Let me ask you a question. Okay, question. What is 2 plus 3? I can literally see you thinking, is he retarded or something? What is 2 plus 3? This is what you ask a bunch of 16 and 17-year olds, or maybe even 18-year olds. You ask them what is 2 plus 3. Most of you jumped right at the answer, I'm sure. 2 plus 3 equal to 5. And for this, let's say this is a 3 marks question. You get 3 points if you answer this question correctly. And if you answered that 2 plus 3 equal to 5, I would give you a small tick and give you 1.5. Huh? Now you're confused. Now you're confused, right? Why would I get only 1.5 if I answered that 2 plus 3 equal to 5? It's a 3-point question, right? Listen carefully. Listen very carefully. Okay. 2 plus 3 equals 5. I'll rub out the marks bit as well. 2 plus 3 equals 5 is absolutely correct in a scalar notation. In a scalar notation. Okay. But when we come to vectors, let's say 2 is the magnitude. Vectors have both magnitude and direction, right? 2 is the magnitude of something known as the a vector, and you'll understand why I'm putting the arrow. It's basically the way a vector is denoted. Because it has direction, we put an arrow on the top of the symbol. So let's say 2 is the magnitude of a vector and 3 is the magnitude of a b vector. Then this becomes a vectorial addition. A vector plus b vector. Okay. And in case of vectorial additions, the answer may lie anywhere between -5 to +5. Okay, anywhere between -5 to +5. And how do we like get at the exact value of the answer? We follow the rules of vector addition, and basically what that entails is that we need to have knowledge about the direction of the vectors as well, how they're oriented with respect to each other, and that direction comes into play when we are doing the vector addition and getting at the exact value of 2 vector plus 3 vector, 2 plus 3, where 2 is the magnitude of a vector and 3 is the magnitude of b vector. You got tricked by that one, right? You got stumped. You thought this is probably the simplest physics question we could ever get in our high school, in the entirety of our high school, right? Well, see, I'm quite a trickster in that way. You just got vectored. You just got vectored, right? That was not a joke out of place. You just got vectored. Okay, okay. Now let us move on to vector addition. I'll tell you how we add vectors. Vector addition. Okay, vector addition. Vector addition. Now, vector algebra, this is what makes it different from scalars, right? That 2 plus 2 is 2 plus 3 is not always 5 in vectors. This is what makes it different, because 2 plus 3 is always 5 when we consider scalars, but 2 plus 3 is not always 5 when it comes to vectors. Okay, so let's see. Parallelogram. You know what a parallelogram is, right? A parallelogram law. A parallelogram is a regular figure, a four-sided figure whose opposite sides are parallel to each other. Okay, now let me first draw my Cartesian coordinate system. This is my y-axis and this is my x-axis, right? The x-axis. X dash, I'll change the color. X dash, O, y dash. Now, let's say I have a vector. A vector has both magnitude and direction, right? Now, let us intuitively, let us consider that the y direction denotes north, y dash denotes south, x denotes east, and x dash denotes west. All right. So, let's say I have a vector which is directed somewhere between north and east. Directed somewhere between north and east, not exactly northeast, but somewhere between north and east. And let us consider this the a vector. Okay, the a vector. And let us also say I have another vector which is directed also between north and east, but somewhat more towards the east side than the north side. And let me call this the b vector. Okay, the b vector. Now you will notice we can segregate, since we denote the vector as an arrow, we can segregate it into a tail. This part is known as the tail and this part is known as the head. And if you'll notice here, the tails of the two arrows, the tails of the two vectors, they are joined together. Okay, now let me take green for this one. I just make a parallelogram having these two sides as the adjacent sides. Okay, let's say that is parallel to the side A, and I'll make that line dotted. Okay, and I'll make another side parallel to side B. That did not turn out right. Let me make another one. Yeah, that turned out right. Okay, and I'll make that a dotted line as well. Then the sum of the vectors A and B, A plus B equals, let me take another color, this color. The sum of A and B is this vector, this line. And what do we call this? We call this the diagonal of the parallelogram, the major diagonal of the parallelogram. Alright, this is the diagonal of the parallelogram, and this, when we join the tail and the two tails of the two vectors together, then the major diagonal of the parallelogram, I'll just label the sides of the parallelogram. This is O. Let's say this is B vector, right? So let's name this B, let's name this C, and let's name this A. Okay, so OBCA is the parallelogram, and now the diagonal OC, it's a vector in itself, and it is the result of addition of the two vectors A and B. And let's name this vector as the C vector, equal to C vector. Okay, now how do we, it's all right making a graph and arriving at the addition, the sum of the two vectors in this way, but that does not tell us anything about the value, is it? If I'm asked in an examination what is the sum of the two vectors A and B, I can't just say C, right? C is any arbitrary name. I can mean C, I can make C such that it means anything, right? So let's see how we arrive at this value. Now, if you know some basic trigonometry, trigonometry, it's very easy to arrive at this value. Let's make another parallelogram right here. Yeah, that turned out pretty good. Okay, and let me make two of the sides dotted. Now that I have drawn this parallelogram, I have to join the ends by the major diagonal, right? This is the major diagonal, and let me draw some arrows. These are the arrows, and let me name this one as A vector, and let me name this one as the B vector, right? So the resultant will be the C vector, of course. Now, how do we get at the numerical value? It's very simple if you know some trigonometry. Okay, let me extend this A vector by a bit. I have extended the A vector by a bit. I have extended the line of the A vector by a bit. I have not extended the A vector by a bit. I have extended the line of the A vector by a bit. Okay, and I made that dotted. And now let us drop a perpendicular from this vertex. Let's drop a perpendicular from this vertex down to the extended line of the A vector. Okay, and now let me proceed. Okay, this is the B vector, right? This is the B vector, right? The B vector. So what do you think? Say this magnitude of this B vector is, suppose, 2 units. Okay, so what do you think the magnitude of the length of this line will be? What do you think the magnitude of the length of this line will be? It will be the same as B vector, right? It will be the same because it's a parallelogram. And in parallelograms, the opposite sides have equal lengths. So can we say that the magnitude of this line is the same as that of B vector? Yeah, and let's say the magnitude of B vector is B without the funny arrow on the top, okay? And let's say the magnitude of A vector is A without the funny arrow on the top. You will see that this is actually how they are depicted. There's also another way to depict them. I'll tell you about it right now, okay? If this is, suppose, the A vector, the denotion, how we denote the A vector, then the magnitude of A vector equal to the magnitude equal to magnitude equal to either just A without the arrow, or we put something known as a modulus sign or a mod sign, and we enclose the A vector inside that. Okay, so this is how we denote the magnitude of a vector, and this is pretty important, so I'll put a cloud around it. Okay, So let's say this is B, the magnitude of this line is B and the magnitude of this line is A. Okay. And now let's say the angle between the two sides of the parallelogram between the A vector and the B vector is theta. Okay, is theta. Now from basic geometry, you can pretty much see, right, these are two parallel lines and these are corresponding angles, right? So this angle will also be theta, since corresponding angles are equal when two parallel lines are transected by a transversal. This angle will also be theta. Now from trigonometry, let's say this length is x. This length is x from the vertex of the A vector to the point where the perpendicular from the C vector meets the extended line of the A vector. Let's say this distance, this length is x. And let's say this length, the length of the perpendicular dropped from the vertex of the C vector to the line extended from the A vector is h. Okay, h. Okay. Now let's jump into trigonometry 101. Okay, let's jump into trigonometry 101. What do you think the cosine of theta will be? Cosine is the base by hypotenuse, right? And in this case, the base is x and the hypotenuse is b. It's pretty well visible, right? The base is x and the hypotenuse is b. So cos theta is x by b. Can we rearrange it? Yes, of course we can. We can say that x equals b cos theta, right? It's just cross multiplication. It's nothing too difficult about it, too abstruse about it. It's just cross multiplication, right? Now let's move on to another important quantity, that is sine of theta, right? The sine of theta or sine theta. What do you think this is going to be? It's h by b, right? Pretty simple. It's going to be h by b, h by b, or h equals b sine theta. Pretty easy, very simple, very easy, very intuitive. Okay, now let me just divide the page here because I want to continue on the other side as well, so as not to lose this diagram. Okay, this diagram is important. Okay, now we need to find c. Now if you know the Pythagorean theorem, what do you think? The magnitude of c vector is c, denoted by this. C square equals a plus x. A plus x is the length of this entire line, right? The length of this entire line. A plus x whole squared plus h square. H is the perpendicular. This is a right angle triangle and c is the hypotenuse. A plus x is the base. H is the perpendicular. So the hypotenuse squared is the base squared plus the perpendicular squared. That's just the simple Pythagorean theorem, right? Something we learn in the 8th standard itself. Okay, so very easy, very intuitive. Now I'll expand the expression. C square equal to, you know how to expand a plus b whole square, right? A square plus 2ax plus x squared plus h squared. Now we plug in the values. You see x is equal to b cos theta, x is equal to b cos theta as we arrived at before, and h is equal to b sin theta as we arrived at before. So c square equal to a square plus 2a, and instead of x we put b cos theta, and x squared is b squared cos square theta, and h square is b squared sin square theta. Very easy, very simple. Now we put this expression b square cos square theta and b square sin square theta, we take b common and put it in brackets. Alright, a square plus 2ab cos theta plus b square brackets sin square theta plus cos square theta. Alright, and what is sin square theta plus cos square theta? It's 1, right? You learn that in trigonometry. You learned it in trigonometry 101. That sine square theta plus cos square theta is 1. Okay? Sine square theta plus cos square theta is 1. It's an elementary relation. So what is the final expression? A square plus, I'll put the b square in front, b square plus 2ab cos theta. Okay, it's very easy, right? Now what the final thing we need to do is we need to remove the square. So c equals root over of a square plus b square plus 2ab cos theta. Wow, that's very, very simple, very, very intuitive, right? And what did we need to get at this very core fundamental concept of vectors? Nothing but a little bit of geometry, a little bit of trigonometry, and a little bit of our good wits about us, right? We didn't let ourselves get vectored by vectors. We didn't let ourselves get vectored by vectors. And that's a very important expression. That's the expression for the sum of two vectors. Okay, that's the expression for the sum of two vectors. And we have a very good name, very nice name for the sum of two vectors. And we call that sum of two vectors is called the resultant vector. Resultant vector. Okay, resultant vector. And you may choose to either learn this as a formula. If you are of the drab and boring kind, you may choose to learn it as a formula, to memorize it as a formula, or you can understand the steps of the derivation. And in that case, you won't need to remember the formula, because even if even if you forget the formula, you know how to arrive at it, right? So it's very simple. It is like this. Okay, and I've also told you about the what we call the sum of two vectors. It's called the resultant vector, right? It's often denoted as the R vector in many textbooks. You can it's a shorthand notation, right? R vector or resultant vector. Okay, now let's speak a little bit about vector subtraction as well. It's very easy. Vector subtraction, once you get the hang of vector addition, you don't need to do much about vector subtraction. Okay, vector subtraction. Now I draw the same Cartesian coordinate system, y and y dash and x dash, y, y dash, x dash, and o. Okay, o. Now I have an a vector and let's say a b vector. Okay, a vector and b vector. Now let's say I want to find b minus a. Okay, b minus a. Now in case of vectors, a very nice sort of cute quality they have is that the sign of the vector plus or minus, it just denotes the direction. Okay, if a vector is say plus b, it means that it's in the positive direction of the conventional axis chosen by us, right? I'm sorry, let's say I have a vector that's in the plus direction. We take this direction, plus x axis and plus y axis, as positive. Okay, so plus b is in the positive direction, and if in the same way I want to talk about minus b, it's exactly 180 degrees opposite to it, right? It's exactly 180 degrees opposite to it, and that makes it in the negative direction. Let's say you have a compass. Let's say you have a compass where north is positive and south is negative, right? So if I have a bearing, let's say my compass needle points in the north direction. So if I take this as positive, when I turn my ship around, it's going to point in the south direction, exactly 180 degrees opposite, right? That's kind of intuitive, and so I call this the negative direction. It's very simple that way. Okay, so the negative of a vector, a minus vector, denotes the same vector in the opposite direction. Denotes the same vector in the opposite direction. Okay, so I just make a 180 degrees angle and see, this is the a vector in the opposite direction. This is the same a vector in the opposite direction, and I call it minus a. I call it minus a. Okay, very simple. Now what do we have left to do? Nothing, right? Nothing. We just make a parallelogram out of the new sides. The new sides are b and minus a. The new sides are b and minus a, because b minus a can be denoted as b plus minus of a, right? B plus minus of a, right? So b plus minus of a, it's that simple. And since we've learnt about parallelogram law of vector addition already, we don't have anything left to do except draw this, except join these two arrows, and we'll be done. This is the C vector, the resultant vector. I'm sorry, not the resultant vector. This has a different name, which I'll tell you about in a few minutes. But this is, let's say it's a C vector, and that is B vector minus A vector. And how do we arrive at C? We just follow the same thing. C equal to root over A square. Only this time, instead of A, we have to take negative of A, since that's the vector we are talking about, minus A whole square plus b square, b is the same, I'm sorry, plus 2 into minus of a into b cos theta. Theta is the angle between the two. Okay, it's just the a that becomes negative, right? It's just the same as before. It's just one of the vectors is in the opposite direction, and so we take it as negative and we proceed from that. Okay, so what's the square of a negative quantity? It's the same as the square of the same positive quantity, right? So minus a whole square is the same as a square, because two negatives when multiplied become a positive, plus b square minus 2ab minus 2ab cosine of theta. It's that simple. It is that simple. It is that simple. You see, this is the result. Very simple result, very intuitive result, very easy to remember result, in case you are the kind of guy that's into remembering a lot of stuff. Okay? Okay, now we have talked about the basics, that is addition and subtraction of vectors, and now I want to tell you about a couple more things, and we'll do that in the next video, which is going to be Introduction to Vectors Part 2. Thank you for watching.